Here we are going to show that a given value is a 0 of p of x, and then find all other zeros of p of x. We're given p of x equals x cubed minus 3x squared minus 6x plus 18, and the given 0 is 3. So we're going to divide using 3 as our divisor, and we'll be dividing into x cubed minus 3x squared minus 6x plus 18. We use the coefficients in synthetic division. 1 will be the leading coefficient in the quotient. 3 times 1 is 3. Negative 3 plus 3 is 0. 0 times 3 is 0. 0 plus negative 6 is negative 6. And negative 6 times 3 is negative 18. Adding 18 with negative 18, we get 0 as expected, because p of 3 must equal 0. So at this point, we know that our p of x is x minus 3 times a quadratic. The second factor is a second degree factor because x cubed divided, or a third degree polynomial divided by a first degree polynomial will have to be a second degree polynomial. Therefore, our quotient, negative 6 is the x to the 0 term, 0 is the coefficient of x to the first, and 1 is the coefficient of x squared. Now, that means that our polynomial is, our quadratic polynomial is x squared plus 0x minus 6. In terms of the quadratic formula, the 1 would be the a, the 0 would be the b, and the negative 6 would be the c. So if we use the quadratic formula, we would get x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And so we're going to have plus or minus the square root of 24. Notice that the two negatives make a positive, all over 2. Now this can be simplified as plus or minus the square root 4 times the square root 6 over 2, or plus or minus 2 square root 6 all over 2. The 2's cancel to give us plus or minus the square root of 6. So the other zeros are square root 6 and minus square root of 6. These are in addition to 3, the given 0. Now, in this case, we had another option as far as finding the zeros of x squared minus 6. Since x squared minus 6 equals 0, we'd have x squared equals 6, and using the square root principle, we would have also got plus or minus the square root of 6. But in general, we'll be using the quadratic formula. All right, so let's go to the to the second example, which is a fourth degree polynomial. And it doesn't matter which of the zeros we start with.
Okay.
Let's start with 1/3.
Okay, talk to you later.
Take them in order. And there's no missing zeros. So we have 3, -7, -37, -17, and 10. 3 is going to be the leading term in this first quotient, the leading coefficient in the first term of this quotient. 3 times a third is 1. -7 plus 1 is -6. -6 times a third is -2. -37 plus -2 is -39. 1/3 of -39 is -13. When we add -17, we get -30. And 1/3 of -30 is -10. When we add the 10 and the -10, we get 0. So P of 1/3 is 0. That does not surprise us because 1/3 we were told is a 0. Now, at this point, we have the coefficients of a third degree polynomial as the quotient. It would be 3x to the third minus 6x squared minus 39x minus 30. But instead of writing that out, what we're going to do is we're going to use the quotient as the next dividend when we divide by the -2. Remember, this time we were given 2 zeros. And so we know that P of x equals x minus 1/3 times 3x cubed minus 6x squared minus 39x minus 30. And now we're going to go to the next step where we're going to also have a factor of x minus -2, which is x plus 2, and a second degree polynomial. So the quotient for this second division will be second degree. So 3 will be the leading coefficient in the quadratic times -2 is -6. Add -6 with -6 gives us -12. -12 times -2 is +24. Add -39 is -15 times -2 is +30. And now this confirms that P of -2 is also 0. We're left with the second degree polynomial, 3x squared minus 12x minus 15. So in terms of the quadratic formula, 3 is our A, -12 is our B, and -15 is our C. So we would have that x equals 12 plus or minus the square root of b squared, which is 144, minus 4 times a times c, all over 2a, which will be 6. So this is 12 plus or minus, and it's the square root of 144 plus 4 times 45, which is 180. All over 6, which is 12 plus or minus the square root. We'd have in the ones place a 4, tens would be a 2, 324, all over 6. Now, 324 is not a number that we readily recognize, but let's factor out. We see that it is divisible by 4, so let's factor out the square root of 4, which would be 2, and when we do that, 4 goes into 32 8 times, and 4 goes into 4 once. So it was 4 times 81. So the square root of 4 times the square root of 81 is going to be 2 times 9, or 18. So 12 plus or minus 18 over 6. This gives us the zeros, the additional zeros are 30 over 6 and negative 6 over 6. These reduce to 5 and negative 1.